All right, so I'm going to show you how we're going to graph this. Keep in mind, I have the advantage of making up my own data. I know what it's supposed to be like. Yours may not quite work like this, and that is okay. So we have a nice little data table here. The bottom is the density of the salt water, and going up the side we have the amount of salt added. All right, so I added okay, well, I'm going to do some math right here. We'll just erase it when we're done. 2 grams of salt to my 100.0 milliliters of water, which has a mass of 100 grams. So I added 2 grams of salt, and my mass of my salt, the mass of the salt water, was 102 grams. Okay. 102 grams divided by the volume, which was 100, is 1.02 as our density. So we're going to, our mass of our salt was 2, our volume is, our density is 1.02. Okay. For the next one, we had 4 grams added to 100 grams of water. That total is 104 grams. 104 grams divide, oh, that didn't work. 104 grams divided by 100 gives us 1.04. So back on our chart, 4 grams, 1.04. 6 grams should be about 1.06. Now yours is going to be a little different, and that's okay. Like I said, I have the advantage of knowing what's going on. But you're going to actually try and graph your actual data. Once you've done that, you're going to draw a line of best fit through it. Okay? Then we're going to figure out the density of our golf ball. Or we've already figured that out. Now that you have this calculated, you're going to go back to find the density of your golf ball. And let's go ahead and write that density somewhere on this graph. All right, my density that I found on the internet was 1.15 grams per milliliter, since we're using milliliters, not cubic centimeters. All right, so on my data table here, I'm going to switch colors. Maybe I'll switch colors. I'm going to find 1.15. Here's my density of my golf ball. I'm going to come up here to where it intersects with my line. In order to have salt water that has the same density as the golf ball, I would need to add 16 grams of water or salt to 100 milliliters of water. All right, so in theory, that would be the same as the golf ball. Now, what did we say at the beginning needs to be true? If we want to make the golf ball float, so we want to have our salt water be more dense than our golf ball. So if 16 grams of salt to 100 grams of water is going to give us 1.15 grams per milliliter, which is the same. If we add 17, that's going to give us a little bit heavier, a little higher density. So add whatever you calculate when you come back over here where it intersects at the left, add a gram of salt to that. Okay? So based on this data, I need to add 17 grams to 100 milliliters of water. Now, if you pour 100 milliliters of water into a beaker, you're going to find that that doesn't work. It's not deep enough. So if we go back and look at our instructions, it says make a graph of the water versus the mass of the salt. Draw a best fit line. Graph a point representing the density of the golf ball. That's what I did in blue. use the graph to determine the mass of salt. I've determined that I'm going to add 17 grams for every 100 milliliters of water. All right. But I'm going to tell you right now that 100 milliliters is not going to be enough. All right. So if I need 17 grams for 100 milliliters, how many grams for 200 milliliters? What am I going to do? 17 for 100. 17 plus 17 for 200. 34 grams. So I'm now going to get a beaker, and I'm going to add 34 grams into 200 milliliters. When you have your solution prepared, you will have Mrs. Heiderich come around with the golf balls, and you'll test your golf ball and see if it floats. All right? And you'll answer the questions down here. All right? That, my friends, is our first lab. Well done.